Let's walk through this Verilog code and try to show some similarities between Verilog and Java. Some people will say Verilog is not a programming language. It's a hardware descriptive language. Let you be the judge of that after we're done. So, you could almost view module as the word class. It's a module gets instantiated just like a class gets instantiated. So like this basic building block is like in Java is a class. Basic building block in Verilog is a module. So in this case, it starts with module Blinky, and all the way down to the end, it ends with a keyword end module. Pretty straightforward. It takes in parameters, which are constants. You could almost view these parameters as also the parameters that would be in the constructor for a Java class or object. So these are constants; they remain the same value for life, and so that's parameters similar to parameters in a class constructor. Then we have a port list. It's all the inputs and output signals that go into the block. You can almost view them as like the public public variables in the class. The inputs are driven by the wrapper calling block, and the outputs leave from this block and are driven out into the design. So you'd almost view it as these could be done. You could do something with setters for clock and reset, and in this case, these inputs, and this output could be you could have a getter. So basically, it's just straight signals instead of having all the setters and getters. Now, in this, just to highlight, clock is like the heartbeat of a module. In hardware, this is like a key signal. It's almost always in every module that's useful. And almost always, whenever there's like a rising edge on this clock, this block is going to do something. Then it waits until another rising edge of the clock. Reset usually happens at initialization, starts out, and when the reset's asserted, all the block state goes to a known initial state. And then in this case, we have the output, which is just one bit. It's like a Boolean that is just high or low, that are 1 or 0. That means the LED would be driven on or driven off. Then we got these registers. And in this implementation of what I'm going to be doing, and most likely for what I'll show you in the foreseeable future, the registers, you can view them as, on the hardware side, as flip-flops. But on the software side, you can view them as you could view them as like private variables. So the outside world does not have access to these. So in this case, we have a single 1-bit Boolean type of signal that we then also connect to this output. And then we also have this counter, just going to be incrementing, and it's a 32-bit value. And so in Verilog, they allow very, bit type of manipulations. It's very important. So like we tell it how many bits instead of a byte, or instead of saying an int or a uint 8 or whatever, you just say you tell it exactly the number of bits. So we got 32 bits, but essentially it's just a 32-bit integer. All right. So that's defining like the public and private variables. Very similar to a class. Then this always block you can view as like the method, or a method, the main method. And in this case, whenever you got a positive edge, a rising edge on clock, this method is going to fire. It's going to run to completion, and then it's going to wait around until the clock comes in and asserts again. And so in this case, when the clock asserts, we check to see if this input value reset n is low, 0. If it is, then we clear the state. Pretty simple. Else, else we're going to drive the value of that LED output to a particular bit. So this is like a bit extraction, 1 bit of this integer. And so this count with -1 is up here. It's coming as parameter. It's 27 minus 1 is 26. So the 26th bit, close to the MSB, but not quite, is going to be driven to this LED, which then goes out and eventually gets to the LED and lights up the light. The counter, basically every time the clock fires, this counter is going to come in and increment. So count equals count plus 1. We can talk more about this being a non-blocking assignment, but we don't really need to worry about that right now. And essentially, that is a simple block. Follow this formula, and you could write almost any other Verilog design. Yeah, so what do you think? This block then gets instantiated into a hierarchy, similar to how an object, a class, gets instantiated. So I think the two are very similar. What do you think? I think that's it for today. Tomorrow we'll talk about the test bench. Shift, print screen. Oops, let's go over here. Shift,